So this is pulling back from the beginning of the year with distribution and combining like terms. When you're combining like terms, one, they have to be alike in order to combine them, right? And then you just add their coefficients. You do not want to confuse adding and multiplying because you're going to be doing both in this particular chapter. And so when we were multiplying like bases, we added their exponents. The exponents increased. But when you are just adding like terms, the exponents don't change. So if I have 1x and 2x's, then here I have 3x's. For this next one, I had to distribute first. So I distributed the 7 to the x, the 7 to the -9. Those are not alike. You were done at that point. There's nothing else you could do. Here I have a 3x, a -4y, and a positive 8y. The 3x does not have anything in common. It stays. The -4y and the 8y are like terms, so you combine those. For this last one, or this next one here, you distribute 3 times x plus 3 times 5. Distribute a -1. -1 times 4x. -1 times -2. And then you have a couple pairs of like terms here. You have a 3x and a -4x, which gives you a -1x or -x. A 15 and a 2 gives you a 17. And so this would have been your final answer here for this one. And then for the last one, you can leave the 6x and the 11 alone for right now. You are distributing a -4. -4 times 2x is -8x. -4 times +3 is -12. Then combining like terms, 6x, -8x are alike. +11 and -12 you can also combine. So that answer should have looked like that. The word term. Term is what we just used when we were combining it. A term is a single number, just a number or a constant. A variable, or the product, so multiplication of numbers and variables. That is a term. That is a term. When you start putting those together with addition and subtraction, that's when you get a polynomial. Polynomial can be written as a sum of terms. It can be a difference as well, but remember, subtraction is just adding the opposite. So that's why it can be addition or subtraction. So then when you start putting terms together with addition and subtraction, you get a polynomial. And so a polynomial is an expression. This is your first definition that you're filling in. An expression that can be written as a sum of terms. A sum of terms. Now we're going to jump to monomial, binomial, and trinomial in your handout. These are 3 basic types of polynomials. A monomial is a polynomial with exactly one term. Exactly one term. That is a monomial. Monomial. Makes sense. Mono means one. Right? A binomial. That's a polynomial with exactly 2 terms. Bi, meaning 2. And then a trinomial also makes sense. A polynomial with exactly 3 terms. Tri. These are separated on your handout, but you have degree of a term and degree of a polynomial. So let's look at degree of a term. Remember, a term is just one of the units. The degree of the term is the sum of the exponents of its variables. The sum of the exponents. That's the third one down on your handout. Sum of the exponents. So then the degree of the polynomial is the highest degree of any term. The highest degree of any one term. Okay? So first, let's look a little bit at some definitions that are not in your book, but I want you to know. Standard form. Standard form. Right, so I do want you to note standard form. Standard form when they are in order from greatest to least degree. And then the next one I want you to know is leading coefficient. So the leading coefficient, that's the coefficient. The coefficient's the number in front of the first term when the expression is in standard form. So you do need to know the term coefficient. Coefficient is the number in front of the term. So if I have 3x, my coefficient is 3. All right, if I have 3x, my coefficient is 3. So let's look at some examples of all of these terms here. The first thing we're going to look at is just what is a monomial. All right. So specifically, it is with one term. Now, I will give you some other cases here that are kind of important to know. Some other cases that are important to know. All right. We're going to start with this first one. One of the rules of a monomial is you cannot have a fractional exponent. All right. So while this is a multiplication of a variable and a number, specifically the variable has to have integer exponents, okay? All right, we have to have, actually, not even integer, we have to have natural numbers. So we have to have like a 1, 2, 3, 4 exponent here, okay? Positive whole numbers, okay? So we could say whole numbers. This is not a whole number. So this would not be a monomial. And that's because my exponent is a fraction. All right, that is not a monomial. And I'm going to kind of divide this into two parts. So we have our monomials that we're going to talk about. I wish this had been split because it's easier to see. We're going to list monomials here. If it's a monomial, we are going to tell the degree. And then we have not a monomial. That's the other piece of it. If it's not a monomial, we're going to tell why it's not a monomial. So you can think of these as like two charts. We're going to go down this list on the left, and it's going to go in one of these two charts. Either it is a monomial, so it is a term, or it's not. And we're going to say why it's not. All right. So this first one is not a monomial, and it is because the exponent is a fraction. Let's look at the next one. We'll look at 58. Is 58 a monomial? Yeah, it is actually. It can be a constant, a term. A term can be a constant, a variable, or the multiplication of those two. And so this actually is a monomial. And now we have to look at what the degree is. So this one's a little tricky. 58. The degree is going to be my exponent on my variable. I don't have a variable. Do I? Right. So the only thing the exponent could possibly be is going to be 0. Because anything to the 0 power is 1, and the variable would actually go away, right? And so anytime you have a constant, the degree is 0. The degree is always 0 for a constant. Let's look at the next one. 2 plus m. Is this a monomial? One term. No, I have a 2. And I have an m. It's actually a binomial, all right? But we are specifically saying, is it a monomial? So in this case, no. This is going to go over here. 2 plus m is not a monomial because it has 2 terms. And we're going to identify other ones too, but this is not a monomial. So this particular one, not a monomial. Okay? Let's look at the next one. Look at the next one, 6x. 6x, is that a monomial? Yeah, because a term can be a number, a variable, or the product. That's just 6 times x. So this is a monomial. So it is this, the degree is all my exponents added up. What's the only exponent that I have here? A 1. So my degree is a 1. All right. Let's look at the next one. Negative 3.4 y to the 4th. Is this a monomial? Why not?
Because you have an exponent.
Yeah, this one's a monomial. Your coefficient can be a decimal, that's fine. Your coefficient can be negative, that's fine. Your exponent has to be a whole number. 4 is a whole number. So, yep, that's my degree. So this is negative 3.4 y to the 4th. My degree is the sum of my exponents. I only have one exponent here, which is 4. So my degree here is 4. All right, let's look at my next one. 3/2 xy squared. Is that a monomial? I didn't say there couldn't be a fraction. I said there couldn't be a fraction in the exponent. Is there a fraction in the exponent? No, my coefficient is a fraction. That's perfectly fine. Coefficient's the number in front. Exponents is the little tiny number up at top. So this is a monomial. This is a monomial. 3/4 is my coefficient. X, y squared. Those are my variables. Now degree, this one's a little tricky. Degree is the sum of the exponents. Yes, it's going to be 3 because I have a 1 on the x and I have a 2 on the y. My degree here is 3. 0, 1, 2, 3, 4, 5, right? Whole number. So my exponent has to be a whole number. What is my exponent here? Negative 2. Is negative 2 a whole number? No, it is not. It is an integer, okay? And so this guy is actually not into the negative 2 is not a monomial because my exponent is negative here. All right, let's look at the last one. What's my exponent here? It's a variable. Yeah, we don't know. That's also not a monomial. Okay, that's also not a monomial. My exponent is a variable. My exponent is a variable. That is also a problem. All right? So let's see what kicked them out here. A fractional exponent kicked it out as a monomial. Now this is a polynomial here because we do have 2 different terms, but it's not a monomial, one term. Negative exponent kicked it out. A variable exponent kicked it out. Let's see what was allowed as a monomial. A constant is a monomial. It just has a degree of 0. Any number multiplied by that variable with the right exponent is going to be a monomial. Doesn't matter if my coefficient's negative and a decimal. That's okay. It doesn't matter if my coefficient is a fraction. That is also okay. All right? Does everybody see the difference between the monomials and the ones that were not monomials? All right, let's look at actually putting these into different forms. So let's look at examples here then. The only ones that you will name are monomial, binomial, trinomial. Anything else, you will just tell me how many terms it has. So a monomial has 1 term, a binomial has 2 terms, a trinomial has 3 terms. That makes sense, right? After that, you just say it has 4 terms, 5 terms, 6 terms. You don't actually have a special name for it, all right? And so they give examples. A monomial, 4y cubed, 8ab squared c. That's all a monomial. It doesn't matter how many variables we have. It matters there was no plus or minus, okay? Look at the binomial, 2x squared plus 3x. We have 2 terms in this polynomial. Polynomial means multi, right? 5x squared plus y cubed, 2 terms. Let's look at a trinomial. 1, 2, 3 terms, all right? And then we have other polynomials. I want to talk about degrees really quickly here as well. The degree of a monomial is easy. We just have the added it together here, so that's 3. The degree of this would be 1 for the A, 2 for the B, and 1 for the C. The degree here would be 4. But then what happens when I get to this guy right here? These are a little trickier. If you look at your handout, the degree of the polynomial, that is the degree of the highest one, highest of any of your terms. So like for this one right here, I have to figure out all 3 of them. So my degree here would be 2 plus 5, right? My 2 plus my 5 is 7. What's my degree of this one? 4. What's my degree of this one? 5. It's in your books, by the way, page 370. So if my degree of the entire thing is the highest one, what is the degree of that polynomial? 7. And that's how you find the degree when it has multiple terms, okay? You find the degree of each one individually, and then you find the highest one, and that is your degree. All right, let's look at standard form. So if you go to the next page, writing polynomials in standard form. All right, standard form goes highest to lowest, and we're talking about exponents, not the numbers in front of it, the little tiny numbers up at the top, okay? Highest to lowest. You also want to combine like terms if there are extra ones. So let's look at this first one. Which one of these terms has the highest exponent? Well, number 1, which one has the highest exponent? 7x cubed. That one is going to go first. Which one is next? The 5x squared. Now, when you put them in a different order, whatever is in front of it is the sign that goes with it, okay? So what's in front of that 5? A negative. So this is minus 5x squared. What's next? 3x. And then what's last? And that's going to be a plus 7. So then if I want the degree here is going to be what? 3. All right, you don't use the coefficient, just the variable. All right, let's look at the next one. For this one, I have x's and y's. So it really, usually you do highest to lowest with your x's, like you're in chronological order. So you're going to use your lowest variable, if that makes sense. So if you had A and B, you would just do A's, and you would do your highest to lowest of your A's, okay? This is actually putting it highest to lowest in degree of terms, okay? So my degree here is 2. And so that's why they're going to list that first. They're going to list that first because that degree is technically higher than the other 2. That degree is 2. And then it really doesn't matter, but you typically do chronological order. So the 3x and, the 2x and the 3y both have a degree of 1, right? 2x has a degree of 1. 3y has a degree of 1. So when you have 2 of them with the same degree, then you are going to put them just in alphabetical order. X, Y. So the x first, then the y. All right, let's look at this last one. What's my highest exponent here? My highest degree is actually the 5y cubed, right? So I'm actually going to put that one first. You notice I put the negative there. What's my next degree? The 1/2 x squared. That's going to go next. And then the negative x and the 6y have the same degree. So I'm going to list them alphabetically. All right. What's my degree of this entire thing here? What's my degree of number 5? 3. So when it's in standard form, you can go look at your first term to figure out what the degree is. When it's in standard form, your degree will always be whatever the degree of your first term is. So go ahead and try 2, 4, and 6 there. 2, 4, and 6. coefficients. So for this one, it says identify the leading coefficient. Once you have it in standard form, the leading coefficient is the number in front of your first term. So the leading coefficient here would be 7. This would be -1. Leading coefficient, -5. Of the ones that you did, your leading coefficient here would be -9. When you don't have one, it is a 1. And then the leading coefficient of number 6 would be 3. 3. Questions on that? All right. Yes. All right. So we are now going to take polynomials, what we were just putting in standard form, and we are going to add them together. So we are adding 2 separate polynomials. We're adding this first one to this second one. The first method they show us is a method called the horizontal method, all right? Horizontal method, where you just take the like terms, the 3x squared and the x squared, so the like term here and the like term there, and you add them. Well, 3x squared and x squared give me 4x squared. And then I go to my next like term, 6x and -1x. And I add those, 6x and -1x gives me 5x. And then I go to my next one, -4 and +3. And I add those, -4 and +3 gives me -1. And so if I were adding those 2 polynomials, I'm just looking across horizontally and I'm saying, well, this is how I'm going to add them. I'm just combining my like terms. So when you are adding polynomials, all you're doing is what you did for bell work. You're combining your like terms, okay? So let's look at the example that they give us. They want us to simplify, and example 3 here is the one I've pulled. They want us to simplify these. We're going to use the horizontal method to do it, okay? So I have a 3x squared. 3x squared. What in the other equation, other side of the polynomial, which one of those is that like term? 8x squared. So I'm going to add 3x squared and 8x squared. That gives me, how many x squareds do I have? 11. All right. Then I'm going to go to my 2x. What's my like term in the other polynomial to my 2x? A -7x, right? A -7x. So 2x plus -7x. How many x's do I have? 2 and -7. -5x. And then I am going to go to my last one. I have a -5. What's in common? A -10. And so I'm going to take -5 plus -10. What do I have there? -15. Now, before I check, I want to make sure that I cannot combine anything else. Can I combine anything else? No, I cannot. That is my answer. Just make sure when you're doing subtraction, when you do your terms, make sure you remember that you are subtracting. 2x minus a -5x. -5 minus a 2 before you combine them to get your final answers. For this one, because a lot of people are having this question. All right, we are adding. So we're going to start with 7x cubed. 7x cubed. What can I combine that with in the other group? Nothing. It does not have a common term. So it stays by itself. Let's look at the next one. Negative 5x squared. Negative 5x squared plus what? Negative 2x squared. All right. Let's look at the next group. I actually have this, negative 3x. Can it combine with anything? In the first group, it cannot. So I basically have 0. The negative 3x cannot combine with anything, so it stays a negative 3x. Let's look at the last one. Positive 2 plus positive 1. And so those are my groups. Those are what I actually end up with. And so then I'm going to just simplify. 7x cubed cannot simplify. What's negative 5x squared and negative 2x squared? Negative 7x squared. The negative 3x cannot combine with anything. And then I have a 2 plus 1, 3. That is my answer for that one. It is my answer for that one. All right, let's look at subtraction. All right, so for subtraction, 6y squared minus, what in the other group goes with the y squareds? The y squared. All right, 4y. So I have 4y minus, don't forget this is minus. What in the second group do I have? Negative 2y. And then negative 1 minus, what's in the second group that combines with negative 1? 0, there's nothing there, so we're going to put a 0 there. And then simplify it. 6y squared minus 1y squared gives me 5y squared. 4y minus a negative 2y gives me positive 6y. And then negative 1 minus 0 gives me negative 1. 5y squared plus 6y minus 1 is my answer there. I do not care which method you use. Some of you will like one method over the other. Okay? I do not care which one you use. It does not matter to me. But some people like it one way or the other. So I'm going to show you both methods. I will always give it to you horizontally, meaning you will have a group plus or minus a group. They will always be spread out. So if you use the vertical method, where you put them on top of each other, you have to make sure you line up like terms. Okay? So you'll notice they went from this, and they make sure it's in standard form, and then make sure you line them up. All right? And then you just add straight down. Let's look at this method here on this page. They've given it to me like this. I'm going to make sure it's in standard form. I'm going to take the first one, and I'm going to add the second one. Right? And then you can just add down. Remember, this is a 1. 1 plus negative 7. What happens here? What's wrong? What's wrong with this if I add a positive 1 and a negative 7? What's my problem? They're not alike. So just because this was 3 terms and this was 3 terms doesn't mean that they just are vertically correct. So what do I need to do? I need to take this guy, I need to shift him over, all right? So make sure when you do this, if I have this right here, it needs to go under the like term. That should go there. 9a needs to go here. And then you'll see that I have one sticking out on the front and one sticking out on the back, right? If you need to, you can write 0 there. You can write 0 there. All right? So just because it has 3 terms doesn't mean they're all going to be alike. All right? Just because they have the same number of terms when you do vertical method does not mean it's alike. When you do horizontal, just because they have 3 terms doesn't mean you can just group them first and first, second and second. They have to be grouped with like terms here. And so when you do this, if you need to put a 0 as a placeholder, put a 0. We have 1 plus 0 gives me 1a cubed. All right? Now they're lined up, 8 and negative 7. They both have a squared. So now I can say that is 1a squared. The 2a and the 9a, those are alike. I can say 11a. I have the 0 and the 3. I can say 3. Okay? The vertical method also works for subtraction. Same page. Difference. Same rule applies for difference, but you are subtracting. So look at that example in your handout. I have negative 5x squared minus 3x plus 7. I am subtracting x squared plus 8x minus 5. I am subtracting here. So you have to consider negative 5x minus 1. All right, so subtraction's a little tricky here. Negative 5x minus 1, that is negative 6x. Negative 3 minus 8 is negative 11x. 7 minus a negative 5. What happens there? They add. So what you may want to do with vertical method is always move the negative through. What do I mean by that? If I have it like this, and I am subtracting, all right, you may want to change it to adding the opposite and make all of those opposite, okay? Does everybody see why that's going to be easier? All right, if you use the vertical method, you may want to do adding the opposite, all right? Because that way you can just add straight down and you can see much easier that it's going to look like that than when you try to subtract.